everyone, and welcome to a new Tank Encyclopedia voiced article. I'm your host Stan, and today we'll be covering the Jagdpanzer 38, the infamous Hetzer. Now, before some of you jump at my throat for calling this vehicle the Hetzer, we will have a very in-depth discussion on the origins of this name and if it is or is not historically correct at the end of this two-part video. So before you go into the comment section and start swearing at me, just have a bit of patience for the second part of the video and then look into that and see if you agree with us or if, well, you don't. Until then, this article has been written by the awesome Craig Moore, who is a book author. He has 3 books out, including German self-propelled artillery guns, Tank Hunter World War I covering the World War I tanks, and the newest book from him, which is called How to Kill a Panther. And it's based on scientific reports from World War II from the British side and how best to kill the Panther. Most of his books are accompanied by lovely illustrations. These are black and white because this is a proof, but amazing color illustrations like you see here on the cover, made by our founder David Bocquelet. So please do check out his books. There will be links in the description. Let's get to it. As the Second World War progressed, it turned into a numbers game. Germany needed more armored fighting vehicles that were cheaper to build and quicker to construct. They started using hulls of captured tanks and reliable but obsolete vehicles, such as the Panzer 38T, to mount anti-tank guns and artillery howitzers. This resulted in the production of the Marder series and the Nashorn anti-tank self-propelled guns. They all carried powerful guns but had very thin armor, an open-topped fighting compartment and a high profile, which made them easy to spot on the battlefield. They could deal out punishment, but they could not take it in return. The Jagdpanzer 38 Tank Hunter was designed to have a very low profile, which made it hard to target and easy to conceal. It was only 2.1 meters high, which was ideal for ambush tactics. It was armed with a powerful high-velocity 75mm PaK-39 L48 gun that could knock out most enemy tanks of the time. It was cheaper and quicker to build than a Panzer IV, a Panther, or Tiger. However, it was not designed to be a close combat vehicle used at the head of an attack like a normal Panzer. This was a self-propelled anti-tank gun that was intended to be deployed on the flanks to stop counterattacks. A pack of Jagdpanzer 38 tank hunters would hide in a wood or thick hedgerow and pick off enemy tanks at long range. The sloping front armor gave the crew reasonable protection from frontal attack, so long as the driver of the vehicle pointed the vehicle towards the threat. The crew could expect to survive a hit from an enemy armor-piercing shell. The thin armor on the sides of the vehicle and at the rear meant that there was a risk of being knocked out by flank and rear attacks with armor-piercing shells. If there was a danger of being outflanked, the driver had to change to a different location quickly. By 1944, the Panzer 38T tank was considered outclassed and obsolete. It had been withdrawn from frontline units already. The Jagdpanzer 38 utilized the tried and tested components of the Panzer 38T tank on a new, wider hull. This meant that the Jagdpanzer 38 was relatively reliable, as all early mechanical problems had already been overcome. Because of this, production could start earlier than usual for a new armored fighting vehicle design, as most of the factory tooling for the manufacture of the Panzer 38T tank was still available. Due to the gun's limited traverse, the driver had to continually change the vehicle's orientation or move to engage new targets. This could reveal the vehicle's location. Now, about the development of the Jagdpanzer 38T. On the 26th of November 1943, well past the midway of the war, the production of the Sturmgeschütz-free assault guns at the Alket Company was severely interrupted when Allied bombers dropped a total of 1,424 tons of explosive and incendiary bombs on their Berlin factory. Before the German invasion of Czechoslovakia, this factory used to be called CKD and built tanks for the Czechoslovak army. On the 6th of December 1943, the OKH, the German Army High Command, reported to Hitler that the BMM company was unable to carry out this type of production order as it did not have the infrastructure to manufacture the 24-ton Stug 3. The factory cranes could not lift a completed vehicle. The BMM factory cranes could only lift 13 tons. It had spent most of the war constructing the 9.8 tons Panzer 38 light tanks for the German army. Hitler then gave orders that the BMM factory was to concentrate on producing a new, lighter Sturmgeschütz. It was proposed this vehicle would have a top speed of 55 to 60 km per hour, weigh 13 tons, and have thin but well-sloped armor to keep the vehicle's weight low. The side armor was only to be thick enough to provide protection from small arms fire and high-explosive shell shrapnel. On the 17th of December 1943, designs for the new vehicle based on the hull of the now obsolete Panzer 38T light tank and a new type of reconnaissance vehicle were presented to Hitler. Both were approved for production. Development work was carried out very quickly. On the 8th of January, the drawings of the final version of the vehicle were finished, and by the 24th, a wooden 1:1 scale model had been built and just 2 days later demonstrated to officers from the Heereswaffenamt, the Army Weaponry Research and Development Agency. The size of the fighting compartment of the wooden mock-up was shorter than on the production vehicle, and the engine compartment had a longer sloped cover. These features were changed to give the crew more room. Now, there were plans to design and mount a 7.5 cm Rücklaufflosse main gun in the production version of the Jagdpanzer 38T. Such a weapon featured a gun barrel fixed to the turret or casemate, which took the full recoil of a shot. However, the development of a Rücklaufflosse gun would take too long. So in the meantime, it was decided that a 7.5 cm Pak 39 anti-tank gun would be installed in the Jagdpanzer 38. This gun was already in production and available for use. Oberst Tomale ordered 3 prototype Jagdpanzer 38 tank hunters to be built and available for trials. It took less than 4 months from the initial design approval to the production of the first prototype. Now, once the final design of the production Jagdpanzer 38 was agreed upon, BMM was awarded a contract to produce 2,000 vehicles. Even more were needed, so the Czechoslovakian company Škoda was also awarded a contract to build another 2,000 Jagdpanzer 38 tank hunters. However, both factories suffered bombing raids. Now, neither of the factories produced the vehicle entirely. They were supplied with components from subcontractors. 316 such companies were based in Bohemia and Moravia in the Czech Protectorate. A further 117 came from other occupied countries and Germany's. Now, neither factory built the vehicle from the ground up. They were supplied with components from subcontractors. 316 such companies were based in Bohemia and Moravia in the Czech Protectorate. A further 117 came from other occupied countries and Germany itself. Due to the advancing Allied forces and constant bombing, the source of parts for construction of the Jagdpanzer 38 changed repeatedly. This caused delays in supply, which affected the monthly production figures. The armored hulls were produced in the steel factory in Witkowice and by the Poli steel mills in Kladno. Both were in the Czech Protectorate. They were also supplied by 2 German steel factories, Linke Hofmann in Breslau and Ruhrstahl in Hattingen. The tracks were cast in the Czech Protectorate at the steel mills of the Chomutov in northwest. The tracks were cast in the Czech Protectorate at the steel mills of Chomutov in northwest Bohemia and Kralovo Pole in Brno. The engines were manufactured by the Czech car manufacturer Praga, which also supplied the Wilson-type gearboxes. A total of 2,827 Jagdpanzer 38T chassis and hulls were produced by BMM and Škoda. About 2,612 were Jagdpanzer 38 tank hunters, 14 were Jagdpanzer 38D Star, 181 were Belgian Panzer 38s, and 20 were Flampanzers. Now let's talk about the design of the Jagdpanzer 38. Due to the limited space inside the Jagdpanzer 38 and the desire to keep the profile of the vehicle low, the gun had to be installed off-center to the right of the vehicle. This enabled the driver, gunner and loader's position to be on the left side of the vehicle, in line, one behind the other. The commander sat on the right side of the vehicle at the rear of the fighting compartment directly behind the gun with his hatch above him. He did not have access to an armored cupola. The gun, as I said, was mounted to the right of the vehicle. This restricted its traverse to only 5 degrees left and 11 degrees to the right. To engage targets outside this rather narrow 16 degrees traverse range, the whole vehicle would have to be moved. The off-center gun mount meant that there was too much weight on the right track and suspension. In order for the vehicle to not tilt towards the right, 850 kilograms of crew and equipment had to be placed on the left side of the gun as a counterbalance. If all the hatches were closed down, the crew had very limited visibility, especially to the sides and the rear of the vehicle. The driver had 2 angled periscopes that protruded out of the upper glacis plate under a protective armored cover. The gunner was provided with a forward-looking Selbstfahrlafetten Zielfernrohr 1A periscope gun sight. The loader had a periscope to look out for threats on the left side of the vehicle. The roof machine gun was aimed looking through a periscope which could rotate 360 degrees. The commander had access to a rearward-looking periscope. If the commander's hatch was closed, he had absolutely no forward vision. It would only be kept closed in extreme emergencies, such as during artillery or mortar barrage. Also available was a SF-14Z scissor telescope which poked out the top of an open roof hatch, which had a magnification of 8 by 10. The Jagdpanzer 38 was powered by a Praga EPA AC 2800 6-cylinder 158 horsepower petrol engine. The Praga engine was very similar to the one used in the Panzer 38T tank, but had been uprated. Instead of producing 129 horsepower, it now produced 158. The engine was connected to a 5-speed Praga-Wilson transmission, which was in turn connected to a planetary steering system. The vehicle had a top road speed of 40 km per hour. This was less than initially hoped for. The production vehicle weighed 16 tons rather than the proposed 13 tons, which also affected the vehicle's top speed. The dome at the back of the tank is a simple cover for the hand crank. Although the Jagdpanzer 38 used an electrical starter, crews were instructed that the preferred method was to use the hand crank where possible, as the electrical starter was not robust and should only have been used in emergencies. To the bottom right of the rear armor plate, there was a port to gain access to the cooling water heater. In severe weather conditions, the engine coolant would freeze. A blow lamp could be placed in this port to warm the coolant and defrost it before the engine was started. When the left rear engine compartment hatches opened, access can be gained to the fuel filler cap behind a 12-volt battery. The Jagdpanzer 38 had 2 interconnected fuel tanks. The fuel tank on the left held 220 liters, while the fuel tank on the right held 100 liters. This would give an approximate operational range of 180 kilometers. Cooling the engine was a problem, as it only had a small air intake vent on the rear deck. It required a powerful motor to drive the air intake fan, which reduced the overall performance of the vehicle because it took power from the engine. Now, although the whole suspension, tracks and road wheels look very similar to those used on the Panzer 38T light tank, the vehicle was a new build. The hull was wider. The Panzer 38T tank was 2.13 meters wide, while the Jagdpanzer 38 was 2.63 meters wide. The road wheels were also larger than those on the Panzer 38T. They were 82 centimeters in diameter instead of the tank's 77.7. The suspension had been made more durable than that used on the Panzer 38, especially at the front of the vehicle in order to cope with the extra weight. The tracks had also been widened from 29 to 35 centimeters. The Jagdpanzer 38 was only provided with one track return roller, unlike the Panzer 38T that had two. The Jagdpanzer 38 driver had a basic instrument panel in front of him. He steered the tank by using two hand tillers. Each one of these levers controlled one of the two tracks. The driver also had a handbrake. The foot pedals were not in the standard orders that we have come to expect in a modern car. The accelerator was in the middle. The pedal on the right was the foot brake and the gear change pedal was on the far left. The gearbox was to the right of the driver. It was a 5-speed Praga-Wilson pre-selector. The Wilson type was the same system used by the British and developed by the Wilson Gearbox Company. The driver did not change gear like you would on a modern car where you put the clutch in first and then select the gear. Instead, while the engine was running, they had to choose the gear first, then depress the gear change pedal, which acted like a clutch, and let it come back up, hence the name pre-selector. To stop the vehicle without stalling, the driver had to remember to select neutral first, then apply the brake and the gear change pedal at the same time. The early versions of the exhaust system at the rear of the Jagdpanzer 38 Tank Hunter had the pipe coming down the back of the vehicle into a tubular silencer box that ran along the top of the rear armor plate mounted horizontally. This tube was changed to a single pipe going into a flame hider on the back of the vehicle later in production. The 7.5 cm Panzerjägerkanone 39L48 anti-tank gun was used to equip the Jagdpanzer IV and Jagdpanzer 38 tank hunters. The German word Panzerjägerkanone literally translates to tank hunter gun and is usually abbreviated to PAK, thus sharing the contraction of the more common Panzerabwehrkanone. It was an electrically fired weapon fitted with a semi-automatic breech mechanism and a 48 caliber long barrel that means 3,615 millimeters. It could penetrate the armor of the most common Allied tanks at ranges of up to 1,000 meters. When traveling across rough ground, the gunner used the internal gun travel lock to minimize any damage to the gun. The SFL ZF-1A periscope gun sight was fixed to the left side of the gun and protruded out the roof in a semicircular sliding section of the roof armor. It moved when the gun moved. It did not rotate on its own, it always moved with the gun. The gunner had to change his body positions to follow the gun periscope as he searched to bring the gun onto the next target by turning the traverse wheel. He also had to avoid being hit in the head by the remote-controlled machine gun handles which were above him. The loader sat on the left side of the main gun, behind the gunner and the driver. He had a very challenging job because the 7.5 cm PAK-39 anti-tank gun had been designed for a loader on the right side. The loader's controls were simply on the wrong side. In order to open the breech, he had to lean across the gun to access the breech opening lever. The main weapon had a semi-automatic loading system. Once the first round was loaded, every time the gun fired, the recoil ejected the shell casing and the breech block remained down in the open position waiting for another shell to be loaded. The large recoil guard was to his right and this got in the way when loading shells. Not all the ammunition was stored near the loader on the left side of the vehicle. Sometimes he would have to reach over the gun breech and the recoil guard to access the shells stowed on the right side of this very cramped tank hunter. The commander had a safety lever near him that prevented the gun from being fired while the loader was servicing the gun. When he was clear of the gun mechanism and a shell was in the breech ready for firing, the commander released the lever to enable the gun to be fired. Design work on the 7.5cm Pak 39 had started in 1939, but it was manufactured from 1943 onwards by Rheinmetall Borsig and by Zeitzer. It used the same 75 by 495mm rimmed ammunition as the 7.5cm KWK-40 of the Panzer IV medium tank and the 7.5cm Stuck 40 gun fitted on the later models of the Sturmgeschütz free assault guns. No towed version of the 7.5cm Pak 39 was ever manufactured. It could fire three common types of ammunition: the Panzergranate 39, an armor-piercing capped ballistic cap APCBC shell, the Sprenggranate 37, a high-explosive HE shell, and different versions of the Granatpatrone 38HL, a high-explosive anti-tank or heat round. The latter was an effective high-explosive anti-tank shell and could be used against soft-skinned targets as well as armored vehicles. Its armor penetration qualities were not as high as the Panzergranate 39 shell. When fired, the APCBC shell had a muzzle velocity of 750 meters per second. Depending on availability, a few rounds of Panzergranate 40 high-velocity sub-caliber tungsten core armor-piercing rounds were carried in case the crew encountered heavily armored Soviet tanks and self-propelled guns. The supplies of tungsten were very limited. The initial design of the gun mantlet of the Jagdpanzer 38 was 200 kilograms heavier than the later design. The early vehicle was very nose-heavy and this put stress on the front suspension. By changing the mantlet to a lighter model later on and making adjustments to the suspension, the maneuverability of the vehicle became tolerable. Now, the loader also had the job of rearming and firing the remote-controlled, roof-mounted, 360-degree swiveling 7.92mm MG34 machine gun. It was fired from inside the armored protection of the fighting compartment, which was a big thing. A hinged gun shield could be fixed in place to protect the crewman when reloading the gun on top. It was aimed by looking through a periscope. Behind him on the rear wall there was the radio, usually an FU5, and the on-off master power handle. The front upper glacis plate of the Jagdpanzer 38 was designed to be 60mm thick, sloped at 30 degrees from the horizontal. This meant that an armor-piercing round fired straight at the front upper glacis plate would have to penetrate 120mm of armor due to the angling. The steep slope would also help increase the chance that the round would just ricochet. The feared Tiger I heavy tank only had 100mm thick effective frontal hull armor. The front glacis armor plate had interlocking welded joints for added strength and security. Sloping the armor also meant that the level protection could be kept high, but the costs and complexity of manufacturing the armor could be kept relatively low. The lower front glacis was 60mm thick but angled at 50 degrees. This would make the effective thickness of that armor plate 78mm. From these statistics, it would appear that the front armor of the Jagdpanzer 38 was very strong. Unfortunately, these figures are deceptive because the armor plate used was of inferior quality to the face-hardened armor used on the Panzer IV Panther tanks. The 60mm armor on the upper and lower glacis was roughly equivalent to 30mm of face-hardened armor as used on the Panzer III. It was manufactured to E22 specification and had a hardness of 265 to 309 Brinell. The upper side armor of 20mm thickness was comparable to the 14.5mm plate used on the front of a SDKFZ 251 half-track. It was made from a low-alloy Siemens Martinite steel with a thickness of 220 to 265 Brinell. The tolerances on armor production were quite wide. The thicknesses of 4 different Jagdpanzer 38 upper glacis plates, which are supposed to be 60mm, were measured. They all belong to the Wheatcroft collection. One was built in February 1945 and the other 3 were built after the war as part of the G13 Swiss contract. The thicknesses range from 62.2 to 64.8. The lower hull side armor was 20 mm thick and sloped inwards at an angle of 75 degrees. The rear armor was 20 mm angled at 75 degrees. The roof armor was 10 mm thick. The belly armor was just 8 mm thick. The shirts and side skirt armor was just 5 mm thick. It was designed to protect the side 20 mm thick lower hull armor from the Soviet 14.5 anti-tank rifles. As with all other German armored fighting vehicles and most produced vehicles anywhere in the world, improvements were continuously introduced during production to improve the performance of the vehicle and increase the speed of manufacture through the simplification of the design. Some changes had to be introduced due to problems with the supply of parts or raw materials. The idler wheel design went through several changes. In order to reduce the amount of time it took to manufacture the rear idler wheel with 12 holes, different designs were introduced in the following order. First, 6 holes in a flat disc, then welded spokes with 8 holes on a smooth flat disc, stamped ribs with 6 holes on a disc-shaped disc, 6 holes on a smooth flat disc, and 4 holes on a smooth flat disc. When Jagdpanzer 38 tank hunters were damaged, the maintenance workshop would fit whatever replacement idler wheels were available in the stores. Sometimes late version vehicles would be equipped with early version idler wheels with 12 holes. If only one idler wheel required changing, then there would be a situation where a vehicle would have idler wheels of different types on different sides. Starting in May and continuing into July, even more changes were ordered. To stop having to open large hatches to the rear of the Jagdpanzer 38 to access the crew compartment, the commander was given a small hatch that opened to the rear. A hatch was added on the lower right to enable access to the radiator cooling filling cap. Another hatch was added to the lower left to give access to the petrol fuel tank filling cap. The heat shield around the exhaust was no longer fitted, and 3 mushroom short-threaded cylinders were welded to the top of the Jagdpanzer 38 to enable a 2-ton temporary crane to be mounted to help with mechanical maintenance, replacement of heavy parts, and repairs. Production line changes were introduced in September 1944. To protect the crew from Soviet 14.5mm anti-tank rifles being fired at the lower hull armor, the Jagdpanzer 38 tank hunter was fitted with shirts and skirt armor plates. Crews found that these plates were ripped off as they brushed past bushes and trees. The front ends of the Schürzen were bent in towards the hull to try and stop them being torn off. The front set of leaf springs experienced more stress than the rear set and often broke. The thickness of the front set of 16 leaf springs was increased from 7 to 9 mm. The rear set of 16 leaf springs remained 7 mm thick. More design changes were implemented in October 1944. The design of the driver's periscope mounting had to be altered after the early version acted as a shell trap. When incoming armor-piercing shells hit the front upper glacis plate but failed to penetrate it, they would slide upwards and enter the crew compartment via the protruding cover over the driver's periscopes after getting caught into it. The armored cover was no longer fitted. The holes were cut flush with the glacis plate to hold the periscopes. A thin sheet metal dual-purpose sun and rain guard was installed over the holes. If a shell slid up the glacis plate and hit the guard, it would rip off the guard but would not act as a shell trap. New road wheels were also introduced that were riveted instead of being bolted. It had been found that some of the bolts on the earlier versions of the Jagdpanzer 38 tank hunter's road wheels came undone, which is not a fun thing to happen when you're moving. The red-hot glowing exhaust pipes and flames of a backfire could give away the position of the vehicle at dusk and during the night. This could result in it being spotted by an enemy artillery forward observer and calling in an artillery barrage, or being observed by the target you're meant to hit. The cylindrical silencer was replaced with a Flammvernichter exhaust. Allied bombing also disrupted the supply of ball bearings. The gun mount then had to be changed. The ball bearings used in the gun mount were replaced with roller bearings, and this necessitated the installation of a spring compensator to help with the elevation of the gun. Filling the Jagdpanzer 38's fuel tanks took a lot of time. In order to enable the tanks to be refilled faster, a larger nozzle with an overflow pan was fitted. Also, there had been reliability problems with the electric fuel pump, so a Solex manual hand pump was issued. The commander's hatch was equipped with a head cushion. As the cold weather arrived in November 1944, just in time for winter, a new heating plate was fitted to keep the battery from freezing. The heating inside the crew compartment was also upgraded. A better heat distribution vent was installed in the engine compartment firewall. It gave more even heat distribution inside the vehicle. The water pump also was upgraded to one that was more robust. By changing the location of an internal stowage box to the right of the commander's position, a further 5 75mm shells were also able to be carried. The last batch of changes started in January 1945. The Model 6 final drive had a gear ratio of 12:88. They suffered from mechanical failure due to the stress put on them. The Jagdpanzer 38 was 3 tons over the initial design specifications. It was front heavy and the driver regularly had to maneuver the whole vehicle to enable the gun to be aimed at the new target. In January 1945, a new, more robust Model 6.75 final drive was fitted, which had a gear ratio of 10:80. The Jagdpanzer 38 was an ambush vehicle and needed to hide. To make the crew's task of fixing cut tree branches and bushes to the exterior of the vehicle easier, U-shaped brackets were welded to the upper front glacis plate and the side armor. Wire or string could be threaded through these U-shaped brackets and foliage tied onto it. The exact date in 1945 this feature started to be added onto vehicles is not known. In order to strengthen the towing brackets on some vehicles, side supports were welded at the junction of the whole side armor and the front and rear armor plates. Others had the extended hull armor towing brackets removed and replaced with U-brackets welded onto the lower front glacis plate and the rear armor plate. That's all for this video. Make sure to follow our website. We'll be releasing new articles on the regular. You can follow us on Facebook, Twitter, Instagram, or Reddit, and if you use Discord, there's a link to our community server in the description. Also, likes, comments, and subscriptions on YouTube are greatly appreciated. If you would like to help us continue to develop and expand, also consider donating on Patreon or PayPal. All of the funds will be used to help us enhance and design new articles and features for you. Until next time, keep us in your sights.